Hello friends, Mr. Burrell here. We're in the very last lesson for Unit 10. We're talking about, this is the Intro to Trigonometry unit. We've been talking about angles, all sorts of different things with angles. We just finished talking about some special right triangles, some 45, 45, 90 triangles, and 30, 60, 90 triangles. This last lesson is just going to be a major overhaul review of right triangle trigonometry. You've already learned everything in this lesson. In Math 2, you should have anyways. So everything that we discuss in this lesson is going to be review, because this combined with everything we've already discussed will be very helpful in Units 11 and Units 12, Unit 13, when we continue talking about some different aspects of trigonometry. So let's hop in. Here are the objectives for the lesson today. Notice that there are a lot. I'm going to read through them briefly. The reason there's a lot is because all this stuff you've already learned. It's just going to be a review. So by the end of this lesson, we'll want to be able to use the Pythagorean theorem, know how to use the Pythagorean theorem to find missing side lengths. You should know the sine, cosine, and tangent values of an angle. You should know that sine is opposite divided by hypotenuse, cosine is adjacent divided by hypotenuse, and tangent is opposite divided by adjacent. You should be able to remember all those things after today. You should be able to find sine and cosine and tangent values and their inverses given of a given angle using a calculator or Desmos, whatever you're using. You should be able to use properties of sine, cosine, and tangent to solve for missing side lengths in a right triangle. Use sine, cosine, and tangent to solve for missing angles in a right triangle. And find the ratios of these trig functions, secant, cosecant, and cotangent. Those are our honors topics, secant, cosecant, and cotangent that you've been exposed to, but that we'll review today. So, as a reminder, this is hopefully relatively familiar to you. Hopefully you've heard that before. SOHCAHTOA. That is the acronym to help us remember that sine of an angle is equal to opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. Tangent of an angle is opposite divided by adjacent. Well, let me go back. If you need to write that down at the top of your guided notes or at the top of a piece of paper so you can remember it, feel free to do that, because that's going to become really helpful throughout this lesson and in the upcoming units. So for using this triangle, we want to find each of these trig function values in fraction form. So I'm going to do all the a ones first. So sine of a, cosine of a, and tangent of a, because when I'm looking at this angle right here, this is my adjacent side, my opposite side, my hypotenuse side. So sine is opposite over hypotenuse, or 8 over 17. Cosine of a is adjacent over hypotenuse, or 15 over 17. Tangent of A is opposite over adjacent, or 8 over 15. Now, if I'm looking at angle B, this is now the opposite and adjacent sides. So sine of B is opposite over hypotenuse, or 15 over 17. Cosine of B is adjacent over hypotenuse, or 8 over 17. And tangent of B is opposite over adjacent, or 15 over 8. So that's what sine, cosine, and tangent represent. They are these relationships between the different sides of a right triangle given a specific angle. These relationships will exist every single time, all the time. That's what makes them so cool, is that if I have this triangle right here and this triangle right here with this same angle, if I knew this side, and this side, the sine, cosine, and tangent fractions would stay the same. Even though this triangle is smaller, this triangle is bigger, the ratios of those sides would stay the same. Every time. Pretty cool relationship that happens with right triangles. Okay, so what if we don't know all the side lengths? Well, if I don't know the side lengths, and I'm trying to find other side lengths, if I know 2 of the side lengths and I'm trying to find a third, I can use the Pythagorean theorem. The Pythagorean theorem, Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs, or these short stubby sides of a right triangle, and c is the hypotenuse. So if I know 2 of the side lengths of a right triangle but don't know the third, I can use the Pythagorean theorem, a squared plus b squared equals c squared, to find that missing side. And we'll do some examples of that here in a bit. And then one other kind of reminder about right triangle trigonometry is inverse trigonometry functions. So an inverse sine or tangent or cosine undoes the sine, cosine, or tangent allowing us to solve for the angle measurement. So earlier on the other page, I said the sine. So if I was looking at this angle, this is the adjacent, the opposite, and the hypotenuse side. So I know that the cosine of this angle, theta, is 9 divided by 12. I called this theta, if you don't remember, that's just a Greek letter. It's like X or Y or Z or Q, whatever. It's just a letter to represent this angle that we don't know. So I know that the cosine of this angle is going to be 9 divided by 12 because it's the adjacent divided by the hypotenuse. So our inverse, we can undo cosine and solve for this angle using the inverse cosine function. And that's in your calculator. If you have like a calculator that has sine, cosine, and tangent on the calculator, it's the second sine or second cosine. It'll pop up that little sine -1, cosine -1, tangent -1. If you're using Desmos, if you put an exponent of -1, it'll do the same thing. It'll have an inverse sine, inverse cosine, and inverse tangent. So here, in order to find what the angle is, I do the inverse cosine of 9 divided by 12. So just for example, in my calculator, the inverse cosine of 9 divided by 12 is 41.4 degrees. So this angle right here would be 41.4 degrees. So that's kind of the crash course on everything that you've learned in the past about right triangle trigonometry. Now, let's do some sample problems. Let's do a couple of these. I'm going to do like 1 and 3. So here I have 2 of the sides of a right triangle, and I want to find the third side. So when I'm just dealing with sides of a right triangle, I use the Pythagorean theorem. A squared plus b squared equals c squared, where a and b are the legs of the right triangle, and c is the hypotenuse, or that long side. Well, here, 6 squared, that's a 6, not a 0, plus 8 squared equals c squared. That relationship will always exist with right triangles. A squared plus b squared will equal c squared. Pretty cool. 6 squared plus 8 squared, let's see, 6 squared plus 8 squared, that's 100. So 100 equals c squared. And then in order to solve for c, I have to square root both sides and get c equals 10. The square root of 100 is 10. So this side length right here is 10 centimeters. I found that using the Pythagorean theorem. If it's one of the legs I don't know, so here I have a squared plus b squared, I don't know this side over here, equals c squared. So I have to rearrange this equation a little bit before I can solve for b. So I'm going to go ahead and subtract 5 squared on both sides. So b squared is equal to 7 squared minus 5 squared. Well, that's 49 minus 25. 49 minus 25 is 24, so b squared is equal to 24. When I square root both sides, the square root of 24 is 4.9. So the length of this side would be 4.9 centimeters. That's the Pythagorean theorem. A squared plus b squared equals c squared. When I'm just dealing with the side lengths of a right triangle, I use the Pythagorean theorem. Okay, here's an example of some problems. It says find the remaining 2 side lengths using sine, cosine, and tangent, and or the Pythagorean theorem. So I'm just going to focus on finding one of the sides. So here I'm going to find this side. Here I'm going to find this side. Okay. So notice that I know one angle and one side, but I don't know this other side. This side is what I'm trying to find. So since I have angles and sides that I'm dealing with, I'm going to be using trigonometry. I'm going to be using my sine, cosine, or tangent values. So according to this angle, this is the adjacent side, the opposite side, the hypotenuse. So thinking back to our SOHCAHTOA acronym, which of my trig functions is going to be helpful here if I'm trying to find this side? Well, this is the opposite side. This is the hypotenuse side. Those are the 2 sides I'm dealing with. Opposite, hypotenuse, I'm going to be using sine. So sine of 30 degrees is equal to opposite over hypotenuse. Sine of 30 is equal to x over 6. Well, sine of 30 is something that my calculator knows how to do. My calculator has this endless arsenal of a bunch of different triangles that have 30-degree angle measurement, and it knows what the sine, or the opposite divided by hypotenuse ratio, is going to be for all those triangles. In this case, I typed it in my calculator. Sine of 30 is 0.5. So 0.5 is equal to x over 6. Well, now in order to solve for x, I'm going to multiply by 6 on both sides, because that'll cancel out the 6 over here. 6 times 0.5 is 3. So the length of this side here is 3. Notice, if you remember from the last video we watched when we were talking about special right triangles, you already knew that. Because I know that the shorter side of this right triangle, if this angle is 30 degrees, is half the length of the hypotenuse. Ah, that's crazy. That's so cool. Anyways, okay, let's move on to this triangle. I have this angle. This is my adjacent, opposite, and hypotenuse side. I'm looking for this side right here. This is the one I want to find. I know the hypotenuse, so which of my trig functions deals with the adjacent and hypotenuse sides? Well, cosine. So I'm going to write cosine of 20 degrees equals adjacent, or x, over hypotenuse, or 9. Again, my calculator has an arsenal of triangles and knows what the cosine of 20 degrees is. It's 0.9397 equals x over 9. Then I'm going to multiply by 9 on both sides. And I'm going to get x equals 8.46. I usually don't round to 2 decimal places till the very end, so I'm as precise as I can. This side is 8.46. Okay. Now, what if I'm trying to find a missing angle? So I know these two sides, but I don't know this angle. We did an example like this earlier when we were talking about inverse trig functions. So again, looking at this angle, this is the adjacent, opposite, hypotenuse side. Same here, adjacent, opposite, hypotenuse side. So if I'm looking at my SOHCAHTOA again, I'm dealing with my opposite and my adjacent side. So the trig function that deals with the opposite and adjacent side is tangent. So tangent of x is equal to 4 over 8. Well, in order to get x by itself, in order to solve for x, I'm going to have to do the inverse tangent of 4 over 8. I undo tangent with inverse tangent. Kind of like we undid logarithms with exponentials, or we undid square rooting with a square. We undo tangent with the inverse tangent, and the inverse tangent of 4 divided by 8 is 26.57. So about 27 degrees. Well, 26.57 degrees. That's how big that angle is. Same on this one. I'm using tangent again. Tangent of x is equal to 2 over 1. So in order to find this angle, I have to take the inverse tangent of 2 over 1. The inverse tangent of 2 over 1, or just the inverse tangent of 2, is 63.43 degrees. So that angle right there is about 63.43 degrees. So that's the Pythagorean theorem. We talked about using sine, cosine, and tangent to find a missing side length. We just talked about using sine, cosine, and tangent to find a missing angle. So now, for honors, we talked about 3 other trigonometric ratios. We talked about sine, cosine, and tangent, but you've also talked about, let me move this down a little bit so you can see, cosecant, secant, and cotangent. Sometimes we get intimidated by these. I don't know where to put my face. Where do I put my face? Is that okay right there? Okay, sometimes we get intimidated by these because we're so used to SOHCAHTOA, but never fear. Sine and cosine are opposites, or sine and cosecant are opposites of each other. Cosine and secant are opposites of each other. Tangent and cotangent are opposites of each other. So sine is the opposite side divided by the hypotenuse side. Cosecant is hypotenuse side divided by the opposite side. So notice these are just flopped. So sine and cosecant are opposites of each other. Their ratios are flipped. Cosine and secant are opposites of each other. Their ratios are flipped. Tangent and cotangent are opposites of each other. This is opposite divided by adjacent, adjacent divided by opposite. So we're tempted to think that sine and secant, cosine and cosecant are opposites of each other, but no. Sine goes with cosecant, cosine goes with secant. C with S, C with S. Why did they do it that way? I don't know. They just did. So, just deal with it. So, when I'm asked to find the value of the cosecant trig function, cosecant is the opposite of sine. And if sine is opposite divided by hypotenuse, cosecant is going to be hypotenuse divided by opposite. So according to this angle, this is going to be adjacent, opposite, and hypotenuse. So the cosecant of this angle is going to be 13.23 divided by 20. Let's do a secant one. Secant is the opposite of cosine. Cosine is adjacent over hypotenuse. So secant is going to be hypotenuse over adjacent. There's adjacent, opposite, and hypotenuse. So the secant of this angle right here is 5 divided by 3. Yep. Let's do a cotangent one. Let's do this one right here. Cotangent is the opposite of tangent. Tangent is opposite over adjacent, so cotangent is adjacent over opposite. This is adjacent, opposite, and hypotenuse, so cotangent is going to be 5 over 12. So that's a brief rundown on cosecant, secant, and cotangent. Okay, so that's basically all the review that we're going to do. Now I'm going to go over some homework problems. I'm going to go over some of the problems that you'd find on your homework so we can kind of walk through them together. So this is number 11, number 13, 22, and 28. So number 11, I have an angle and a side. I'm trying to find this other missing side. So first I'm going to label my sides. This is the adjacent, opposite, and hypotenuse side. I'm going to go ahead and write SOHCAHTOA up here. So I have the adjacent and the hypotenuse sides that I'm dealing with. So that's going to be cosine that I'm going to use. Cosine of 57 degrees is equal to adjacent over hypotenuse, x over 2. Well, cosine of 57 degrees in my calculator is 0.5446 equals x over 2. So I'm going to multiply by 2 on both sides, and I'm going to get x equals 1.09. So the length of this side right here is 1.09. Okay. Right triangle trigonometry is one of my favorite things. I love all these relationships. I think they're so cool. Okay, this triangle right here, I have another angle, and I'm trying to find, I have a side, and I'm trying to find another missing side. So this is the adjacent, opposite, and hypotenuse sides. I know the opposite side, and I'm trying to find the adjacent side. O and A, that's going to be tangent. So tangent of 51 degrees is equal to 14 over x. Well, tangent of 51 degrees is 1.2349 equals 14 over x. So notice right here, we're tempted to just be like, multiply by 14 on both sides. But notice right here, I'm taking 14 divided by x. I don't like that. So I need to get x out of the bottom. I don't like x in the denominator of a fraction. So I'm going to multiply by x on both sides. So I'll have x times by 1.2349 equals 14. That's better. I like x in the top. I like x being multiplied by stuff rather than something being divided by x. Because now, since x is being multiplied by 1.23, I'm going to divide by 1.2349 on both sides. So 14 divided by 1.2349 is 11.34. So the length of this side is 11.34. Okay, this one over here, I don't know this angle. I'm missing an angle, but I know two of the sides. That's a good sign to me that I'm going to be using my inverse trigonometry functions. This is my adjacent, opposite and hypotenuse side. Which of my trig functions deals with the opposite and hypotenuse sides? Sine. Sine of theta equals 10 over 12. So in order to solve for this angle, I'm going to have to undo sine with the inverse sine of 10 over 12. The inverse sine of 10 over 12 is 56.44 degrees. So this angle right here is 56-ish degrees. Okay, last but certainly not least on the honors topic, cosecant. If I'm trying to find the cosecant ratio, the ratio associated with cosecant, I know that cosecant is the opposite of sine. Sine is equal to opposite divided by hypotenuse, so cosecant is hypotenuse divided by opposite. So here's the angle I'm looking at. Here's the adjacent, opposite, and hypotenuse sides. So the cosecant of this angle is going to be 19 divided by 6 square root of 2. You can simplify that if you want to, right, as a decimal, whatever, but I'd be fine just with that. Some of these problems will be combined with using the Pythagorean theorem on your homework, so watch out for that. But that's really everything. Again, that's a really, pretty quick overview of everything that you've learned associated with right triangle trigonometry. Hopefully nothing in this video was completely 100% new. Hopefully you've heard everything in this video at least a little bit before. But these are all the things that I hope you're able to do after this video. If you have any questions whatsoever about any of this, please, please, please let me know. I hope that was helpful, and I hope that you enjoyed that as much as I did.